This video will illustrate how to use the database write-back feature. This feature allows a dashboard to write data back into the database. Typically, dashboards do not write data back to the database. They merely display the data and allow the user to filter the data in various ways. However, in some cases, you may want your users to be able to modify data in a dashboard and write the data back into the database, where the modified data will then be available to any other dashboards. Before we illustrate how to use the database write-back feature, please note that a special license is required for use of this feature. So if you want to implement this feature in your own application, please contact your account manager for information about the licensing requirements. There are three basic parts to using the database write-back feature. First, you'll need to configure a dashboard table to be editable so that a user can make modifications in the table. Secondly, you'll need to use special script functions to access the changes that the user has made to the table. For example, rows that they have added, rows that they have deleted, or rows that they have modified. Thirdly, you will have to use script to create the SQL statements that will write the data back into the database. These statements will include SQL for adding rows, or removing rows, or modifying the data in certain rows. This example will look at a simple situation where we simply want to allow the user to modify certain rows of a dashboard table and write the changes back into the database. A more complete example of database write-back is available in the documentation. The example in the documentation also provides an illustration of how to add rows and delete rows from a database table. Before we get started with the example, let's take a look at the data worksheet that the dashboard is based on. This data worksheet joins two of the tables from our sample database, the orders table and the sales employees table, into a data block that we call orders data. We've hidden a few of the columns in this result to make the dashboard a little simpler. For example, we've hidden the customer ID field, the duplicate employee ID field, and a couple of other fields. The orders data result will provide the table that we'll use in our dashboard, and that will make editable to users of the dashboard. Note that if you want to try this example yourself, you'll need to create a writable version of our sample Derby database. You can do this by unzipping the orders.jar file, which represents our sample Derby database, and setting up a new data source to point to the unzipped version of the database. Let's now take a look at the dashboard that is based on the orders data block in this data worksheet. This dashboard contains just a single table with all of the visible columns from the final result of our data worksheet. What we'd like to do is to make this table editable by the user of the dashboard so that the user can make modifications in this table and submit their changes into the database so that the actual data in the database is altered according to their specifications. The first step that you'll need to do is to make this table editable. To do that, right-click on the table, select Properties, select the Advanced tab in the Table Properties panel, and then select the Enable Table Editing option. Note that this feature has sub-options including Add Rows, Delete Rows, and Edit Rows. Enable whichever options you want to make available to the user in terms of editing. If an option here is not enabled, then the user will not be able to perform that action. For example, if Delete Rows is disabled, then the user will not be allowed to delete rows from the table. For this example, we'll keep all of these options enabled. Press OK to close the Table Properties panel. Preview the view sheet, and note that you can now make modifications to this table. For example, by double-clicking in a cell of the last name column, you can change the last name of a salesperson. You can insert a new row by right-clicking and selecting Insert Row. And you can delete a row by right-clicking and selecting delete rows. Note that modified rows are displayed with a yellow highlight, inserted rows are displayed with a blue highlight, while deleted rows are not indicated. They are simply removed from the table. Note that these changes are not written to the database until the appropriate commit script is executed. Without committing these changes to the database, the changes will not persist the next time the dashboard is refreshed. In addition to making the table editable, you can also place constraints on the type of data that can be entered into any of these columns. Let's return to the design view, right-click on a column header, and select Column Options. The Column Option panel allows you to specify whether this particular column will be editable or not, and allows you to specify the type of input editor that you want to provide to the user. These are the available options. For this particular column, which is the salesperson first name, a text input control is appropriate. You have the ability to enter here a regular expression that can restrict the nature of the string provided, for example by disallowing numerical characters or special characters. And you can also provide an error message that should be displayed to the user in the event that their input does not match the regular expression check. For numerical columns, you can consider setting an input editor more appropriate for that type of data. Again, select the Column Options property. And in this case, for a column that contains integers, select the integer editor. You can specify a minimum and a maximum value and, again, an error message to be displayed in the event that the user's input does not fall in the specified range. In this case, these values are employee IDs, and since there are only 4 employees in this data set, we may reasonably want to restrict the user's input to values between 1 and 4. We can set a minimum of 1 and a maximum of 4, and an error message that would be appropriate to be displayed to the user. For a field such as discount, which is a decimal value, we can set an appropriate input editor, such as float. Again, we can set a minimum and maximum value if we wish. For example, that the discount should be between 0 and 100%. If you do not specify an error message, a default error message will be displayed to the user in the event that the value falls outside the specified range. For a date field, a date editor is appropriate. Again, here you can specify a range within which the entered date must fall. For example, between sometime in 2015 and sometime in 2018. For Boolean fields, such as this paid field, you can use a Boolean editor that will provide a check mark that the user can either select or deselect to enter the value of 1 or 0. Let's preview this dashboard to see how the user would experience the different editing options that we've set. For text fields, we haven't specified any regular expression to constrain the input, so any modifications at all can be made. For the employee ID field, we specified an integer editor, so the user can enter an integer either by typing or by using the spinner control. Note that if the user attempts to enter a value that is outside of the specified range of 1 to 4, the error that we entered for the column option is displayed to the user. For the discount field, we specified a float editor, so again, the user can enter a value or use the spinner control. And again, if the user enters a value that's outside of the specified range, an error will be displayed. In this case, the error displayed is the default error message. For a date field, the input control is a calendar type widget. And again, data entered that's outside of the specified range will provoke the error message. The Boolean field called paid is represented to the user as a set of checkboxes which the user can select or deselect. We have now completed the first part of setting up a dashboard for database writeback. That is, by making the table in the dashboard editable and by specifying any constraints on the nature of the data that the user should be able to enter into the table by setting the appropriate column options. The next step in setting up your database writeback is to acquire the changes that the user made to the table. You need to determine which rows were modified, which rows were added, and which rows were deleted so that this information can be written back to the database. There is a script function provided for this purpose called getFormRows. The function argument accepts one of three different values: added, changed, or deleted. getFormRowsAdded returns an array of the added table rows. getFormRowsChanged returns an array of the modified table rows, and getFormRowsDeleted returns an array of deleted table rows. Let's just take a look at how this can work in a script. Here we have a submit button in this dashboard with a script attached to it. The script actually contains the full logic to do database writeback, but for now we'll just look at the aspect of obtaining the user input. In this case, just rows that were changed. Let's take a look at the script. In this script, we use the getFormRows function to obtain the rows added, changed, and deleted. But in this case, we're only going to look at the rows that were changed by the user. To display the values of the changed rows, we have a loop that loops through the array returned by the getFormRowsChanged method and concatenates the values from the different columns in the changed rows. The result is then displayed in a JavaScript alert. Let's look at the results. Again, the logic in this script only deals with changed rows. So we'll preview the dashboard. We'll make changes to a couple of the rows. For example, changing Robert to Roberto, and changing Annie to Annette. So we've made modifications to two rows. We'll press the submit button, which will execute our script, which currently only displays the values in the changed rows. And you can see that the results returned by the getFormRows method are the two rows that were changed. The one where the name Robert was changed to Roberto, and the other where the name Annie was changed to Annette. When we create our full database writeback script, this is the information that we will need to commit to the database. So now you've seen part one, which is setting up the user input aspect of the table, and part two, which is acquiring the user input within a script. The third part of implementing database writeback is constructing the SQL statement and submitting it to the database. This again you do within a script, and it can be the same script that you place on the submit button where you acquire the user input. There are a set of functions that you will use for committing data back to the database. The create connection function is used to open a connection to the database. The first parameter is the name of the data source that you've defined in Style Studio. The second and third parameters are login credentials, username and password, that might be required by the database. You will then use the prepare statement function to construct the SQL query that will be sent to the database. This statement will either add rows to a table, delete rows from a table, or update table rows. Obviously, it requires some knowledge of SQL to construct these statements. What you can see here is that the statement involves the use of placeholders, which will be substituted by values from the arrays holding the user modifications. In this example, we're only looking at submitting changes that the user has made to existing rows. This SQL statement will update the sales employees table in the database with a new first name and last name. The actual modified first name and last name are inserted into the SQL statement by using the setString method. The first call to setString inserts the salesperson's first name into the SQL statement, retrieving this first name from the rows changed array. The second call to setString inserts the salesperson's last name into the SQL statement, retrieving this from the rows changed array. And the call to setInt inserts the employee ID into the SQL statement, again obtaining this from the rows changed array. Note that indexing into the rows changed array starts from 0. So the first column of the rows changed array has index 0. After the SQL string has been fully constructed by using the prepare statement method, the setString and setInt methods, you can execute the SQL statement by using the execute update function. The commit function clears the rows changed array and removes any highlighting from the table. Finally, the end of the script should include a call to the rollback method in the event of an error and should close the database connection. Let's test out this script on the actual dashboard. Let's preview the dashboard. And again, keep in mind that the logic we have in this example only handles changed rows and will not submit added or deleted rows. For the full script that includes an example of adding rows and deleting rows from the database, consult the documentation. Here we'll make a couple of changes. Again, Annie can be changed to Annette, and Robert might be changed to Roberto. 2 rows changed in the dashboard table. Then we press the Submit button to commit those changes to the database. And now you'll see that every instance of Annie displays as Annette, and every instance of Robert displays as Roberto, because those values for the first name field have actually been written into the database and are now being read from the database. Therefore, any dashboard that pulls data from the sales employees table in the database will reflect those updated names of Annette and Roberto. We can change those values back the same way that we changed them initially, and that is just by modifying the values in the table and then resubmitting the changes to the database. To review, the 3 parts of configuring database writeback are, first of all, to make the table editable and configure the user input options for each column, implementing constraints as desired on what the user can enter. Then in script to obtain the changes that the user has entered, including added rows, deleted rows, and modified rows, using the getFormRows method. And then again in script to prepare the SQL statement and execute the SQL statement on the database. Again, please consult the documentation for a more complete example of all the database writeback features.